Okay, in Learning Assessment 10.4, we're asked to find the impedance seen by the source. We have mutually coupled coils, and we're going to utilize our problem-solving strategy entitled Magnetically Coupled Inductors. Now, how are we going to proceed here? If we want to find the impedance seen by the source, we're going to need to calculate the current flowing out of the source, I sub s, and then Z sub s, the impedance seen by the source, is going to be 120 at an angle of 0 divided by I sub s. So our task then is to come up with an expression for I sub s, or a value for I sub s. And before we do that, let's simplify this side of the circuit some. Let's take these two elements and let's combine them and simplify this circuit over here. So if we look at, we've got two impedances in parallel, so if we combine them as admittances, we'll have 1 over minus J2 plus 1 over J1, which is 1 over minus J.5, which is 1 over Z. So Z for this part of the circuit is J2. Okay, so now what I want to do is I want to take and redraw the circuit with that combination. So here's our circuit now. We've combined those. It was J2. Since it's J2, I know to draw it as an inductor. And now for our problem-solving strategy, says to find two mesh currents. Okay, here's the mesh current I1. Here's mesh current I2, and again, here's our source current, and of course, IS is equal to I1. Now, let's apply KVL to each mesh in accordance with our problem-solving strategy. And if we start off, we'll have 120 at an angle of 0 is equal to, we have a drop here, which is 2 minus J1 times I1. Okay, now we have two voltage terms for our inductor coil. Okay, we have one due to current I1, okay, and it's going to be this polarity, and it's going to be J2 I1. And we would have that term even if we didn't have mutual coupling. Now, according to our problem-solving strategy, if this current enters a positive terminal, it's going to produce a voltage positive over here at this coil. So there's another voltage term over here due to current flow in there, and this term is J1 I2. Now note that that's the same polarity as this term, so on our equation here we get a plus J1 I2. And if we rearrange that equation, we'll have 120 at an angle of 0 is 2 plus J1 I1 plus J1 I2. Okay, now for the right-hand side, okay, we'll have 0 is equal to 2 plus J2 times I2. Okay, that's a drop across those two. Now, we're going to have two voltage terms here, one due to current I2 flowing, which will produce a voltage like that. That'll be J2 I2. Okay, now, we have the coupled coil, we have the current I1 entering the dot. It's going to produce a voltage over in this second coil, this J1 I1. Okay, so on our equation here, we'll get a term that's J1 I1. So if we rearrange our equation, we'll have 0 equal to J1 I1 plus 2 plus J4 I2. Okay, now, what we really need to do is we need to solve for I2 in terms of I1 and substitute in one of these other equations. In other words, we need to eliminate I2. So let's take this equation And let's write it as 2 plus J4 I2 is equal to minus J1 I1. And that's going to give us that I2 is minus J1 over 2 plus J4 times I1. Now, what we'll do is we'll take this and we'll substitute it in to this equation for I2. So now we have 120 at an angle of 0 is 2 plus J1 times I1 plus J1 times minus J1 over 2 plus J4 times I1. And now if you remember, this is I2. Okay, so 120 at angle of 0, and if we simplify that, this becomes 2.1 plus J.8 I1. Okay, so I1 then becomes 120 at an angle of 0 over 2.1 plus J.8. And if we remember, I1 is equal to IS. And we says that ZS, we said was 120 over IS. So we have 120 at an angle of 0 divided by 120 at an angle of 0 divided by 2.1 plus J.8. And that gives us that Z sub S is 2.1 plus J.8 ohms.